Thank you and welcome to my presentation. Have you ever seen a structured glass element melt like ice cream on a hot summer day? My name is Maximilian Möckel and I'd like to talk about fire safety. Maybe you know this example. It's the address hotel in Dubai in 2016. Highly combustible facade panels allowed the fire to spread over the building, and as you can see, also over the buildings on the ground. And I have a second example. You may be more familiar with it. It's the Grenfell Tower in London in 2017. It's the same case. Highly combustible facade panels allowed the fire to spread very fast over the building. But what about glass construction? As you can see here, the Apple retail store in New York, what would happen to an all-glass structure like this in the event of fire? To see this case, we can use the power of AI, and how this can look like, we can see in the next picture. As you can see, there are melted glass beams and a completely destroyed structure. And sometimes I get asked if there are so many applications that it's worth to look in detail in this topic. And I will say, yes, there are many applications, and I'd like to show you some of them. My first example is a simple glass partition wall. It separates one room from another, or the fire from the user. And in the event of fire, if the glass partition wall fails too early, the fire spreads over and the person dies. My second example is a glass roof with a substructure made of glass, as you can see in the picture. And in the event of fire, it maybe fails too early, the glass substructure melts down, the roof falls down, and the person dies. My last example for today is walk-on glazing, as you can see in this picture, and it's the same case in the other ones. If in case of fire the structure melts down, the person falls through and the person dies. As you can see with these three examples, the combination of glass construction and fire safety engineering offers many applications to look more in detail. But for my research project FiReGlass, I would like to leave these two examples out, because for the research project we aimed just for glass beams. We aimed for fire-resistant glass beams because the regular glass beams, as you can see in this picture, lasted only 25 minutes in case of fire. And we wanted to extend this fire resistance time, and therefore we used a regular glass beam, as you can see here, and applied thin glass panels on the edge and the outer surfaces, and the cavity was filled with a fire protection gel. The finish of the setup is then the support area where the protection systems come together. In this picture, you can see a cross-section of our beam, and you will see the functionality of it. So if we apply a fire on this glass beam, the gel foams up and protects this load-bearing element, and the temperature keeps the temperature as low as possible. To apply a mechanical load to our beam, we leave part of the ends of the beams unprotected, so we can apply a mechanical load to the beam, and the fire protection gel does not have to bear the load, and we have at the same time a fully protection system. We then applied our first specimens in a fire test, as you can see here. We tested 3 specimens at the same time with a mechanical load on top, and after finishing the setup and closing the oven, we started burning the chamber. On the next slide, we will see a short video of our tests. As you can see, we had a small window to look inside the oven during the test. And what we will see is just a cutout of this beam here in the middle, and we will see the beam from below. You will see here the exactly time when the gel foams up. If you have a closer look to the edge of the beam, you can see that the gel foams up very much and expands a lot. So this is our result. We have a fully burned glass beam, but as you can see with the red line, we can see that the load-bearing element stays in a normal level and we have no deformation. We can see here in the bottom picture that the load-bearing element has no deformation. To show the functionality of our system, we applied glass beams to our demonstrator. And on the left, you can see a simple laminated glass beam. And on the right, you can see the laminated glass beam with the protection system around it. We then applied the same beams again in this demonstrator, but these two beams were in the fire test I showed you on. On the left, you can see the normal glass beams lasted just 22 minutes, and on the right, you can see our new developed beam that lasted 40 minutes in the fire test. I think this is a good indication for what our beam can do, and in future, hopefully, we can build buildings as safe as possible, as you can see here in this generated picture. And you are very welcome to visit my demonstrator about over there. And thank you for your attention.